Okay, so what we're going to do is we're going to make our system, and then we're going to solve it. So a little bit different than the other day. You didn't have to make your system. Now it is similar to what we did in previous days where we have to define our variables. So if you read here, it says how many $5 bills and how many $1 bills. So the number of one type and the number of another type is going to be X and Y. So it doesn't matter what you put here and here. I'm going to say that X is the number of $5 bills and Y is the number of $1 bills. Okay? So we have a total of 27 bills. So number-wise, the number of fives plus the number of ones is equal to 27 total. Okay, so this is our equation in terms of the number. Okay, now value. There's a total value of $47. Well, X $5 bills is not worth X dollars. This is a number, so you have to take the number times the value per bill plus the number times the value per bill. I'm putting those labels in there. You don't need them. I'm just putting them so you understand that. So your system is this. The number total to be 27 and the value totals to be 47. So I like doing substitution or elimination. So I'm going to multiply this by -1. And so then I get the y's to cancel off. So I have 4x equal to 20. X equals 5. The number of $5 bills is 5. So then the number of $1 bills, we could almost figure it out, is going to have to be 22. Five fives is worth $25, and 22 ones is worth $22 for a total of $47. So that makes sense, value-wise. Okay. So the next one, we've got adult tickets and student tickets, and we don't know how many of each. So again, we're going to let X represent the number of adult tickets, and it doesn't matter what you do, adult or student. So I'm going to let X represent the number of adults attending, which is going to be the number of adult tickets, and Y be the number of student attending, which is the number of student tickets. So we have a total of 55 people attending. So the number of adults plus the number of students is 55. The revenue generated by this many adults attending is going to be $7 per ticket times the number of tickets. So that's the revenue generated by X adults attending. And this would be the revenue generated by, no, it's $4, sorry. $4 a ticket times the number of student tickets equals a total revenue of $295. So again, I like elimination, so I'm going to multiply this by -4 to cancel off the y's. -4 times 55 is -220. So it looks like X is 25. The number of adults attending is 25. How do we find the number of students attending? Well, plug it back into any one of these original equations, and that's just the total number is 55. So if we've got 25 adults, then we're going to have 30 students. And I'm sure if you check the revenue of that, it's going to total to be $295. Okay. Okay, so I do have one more. It's not a problem where you have to make the system. You just have to solve the system. So remember that when you're solving a system, you want the equations to be in standard form, which means the x's and y's on one side and the constants on the other. That's not the case here. Okay, so I'm going to subtract 2y to get the y's on the left and add 4 to get the numbers on the right. So the first equation would be 3x minus 2y equal to 4. And then if I added 4x to the bottom, I have 4x plus 5y equal to 13. You know, just as a review here, we need to eliminate either the x's or the y's. So I think I'm going to eliminate the y's. So I'm going to multiply this one by that coefficient and this one by that coefficient. Now I want to make them opposites. So I'm going to make this a positive 10, this a negative 10. So x equals 2. Now again, always plug back in the value that you know into one of the equations, right? So you could plug it into the first equation. Or the second, doesn't matter. So remember, when you're solving for y, you're going to divide last. You're going to get rid of this 6, so I have to subtract 6. This is a positive 6, so I'm going to subtract 6. So y equals 1. So we have the ordered pair 2, 1. So that's what we do for that. So good luck.